Okay, we now have the basic boat created. I'm going to use a tool called Configuration Manager, and this allows me to look at the boat in several different configurations. One configuration is I want it actually shelled out, so it looks like the actual finished boat, and the other is I want it to, before it's shelled, so I can actually take the entire volume of the boat and let SolidWorks do the calculations for me. So I'm going to go over here, I'm going to select Configuration Manager tab right there. I'm going to select this right here, and I'm going to create Add Configuration. And the name of this configuration is going to be Basic Boat Not Shelled. And I just give it the name that kind of defines what it looks like. Now you can actually do some advanced things here. You can actually add additional color and make it look a little bit different so you know what configuration you're actually looking at. I'm not going to worry about that right now. I'm just going to go ahead and create. And now you notice under configuration we have two. We have the default and we have not shelled. So I'm going to double click on that, make sure it's active, come up here and select the configuration tree there, and now I'm going to go back to the shelled part and I'm actually going to suppress it. Okay, so now the shell is suppressed, you can't see it. You go back to Configuration Manager and let's look at the basic cardboard boat design. Double click on it and it is shelled out. So we can jump back and forth, and you notice as we do this, we go back to this right here and look at mass properties, it's going to give you a different answer because basically it's different. Your center of gravity is going to be the same pretty much, but your mass and your volume is going to be different. So that can be a little bit helpful. Now the next thing I'm going to do is I'm going to actually double check the hand calculations here and kind of find out where my freeboard is. Or actually what I really want to find out is where is my water line? How far is this going to sink in here? And I'm going to use the same values as I did on my hand calculations. The boat here, let's just take a look again, double check. The boat mass properties says that it's going to weigh close enough to basically 11 pounds. So I'm going to use 11 pounds in my calculation. And actually, if you want to be safe, this is the balsa, but you're going to actually add duct tape to it, which is going to be a couple more pounds. So maybe if we just say 15 pounds. And then our riders, we have two riders, and it's probably going to be, say, 435 pounds total. So that's the same value that I'm going to use in here. So to do that, we're going to have to actually find out what that is. We use 15 pounds for the boat and 435 for the riders, and that ends up being 450 pounds. Okay, so we have 450 pounds, and we need to divide that by 62.4 pounds per cubic foot. So in doing so, our pounds cancel out, and our final answer will actually be in just cubic feet. So let's go ahead and take that value, 450 divided by 62.4, and it ends up being 7.21 cubic feet. So I'm going to go ahead and take that 7.21, and you can take the precision out further if you want, but I think for our purposes, two places is going to be fine. So I'm going to take 721 cubic feet, and I'm going to multiply that by basically 1 foot. I'm going to convert that over to cubic inches, so I'm going to multiply that by 1728, and that gives me 12,458.88 inches cubed. Okay, and this is the volume required to float the boat, or basically that is the volume of this that I need to find, and that's where it's going to displace, actually be equilibrium with the water. So how am I going to find that? Basically, from Dr. Penny's approach, you find H and then subtract for the freeboard. Well, I'm going to show you just another method, and either method for a simple geometry like this is fine, but with more complex geometry, this is going to be really helpful. So the process is, I'm actually going to take this right here, and I want to actually go back into not shelled, configuration. I'm going to come down at the bottom here and I need to create a plane, a reference plane, and I'm going to come off the bottom right there, and I want to go up. The distance I don't really know. I'm just going to kind of guesstimate right now. Let's go say 7 inches. And we need to flip the direction and say OK. And then we have a plane coming up here. And I use this plane as a cutting plane, so I can come up here and go to Insert, Features, and I want to split this. Okay, so I'm going to use this plane as a split tool, and I want to cut the part, and I want to actually take body 2, and I want to consume the body. I want to take body 2 and consume it, basically do away with it. So I'm going to go ahead and check that. Now that's our finished part right there. So we're going to use SolidWorks to find the volume of that. So I'm just going to come back up here to Evaluate and Mass Properties, and let's check the volume here. It's in cubic inches, and that's 10,192. And what we need to find is the height at 12,458. So 7 inches, we are actually pretty close, but we're going to have to it's going to sink down a little bit further than that. So I'm going to use this tool right here to actually modify that value. We went 7 inches, so I'm just going to modify that plane, and let's just jump it up to 8 inches. Evaluate. And evaluate it and see where we're at. 11,648. So we're actually getting a little bit closer. It's going to sink down some more, so we're just going to have to keep bumping that up. Let's just jump it to 9 and then come back down if we need to. So let's take that and Mass Properties and see how fast this is. I mean, it is a little bit cumbersome, but it is pretty darn fast. So 12,458 is what we're shooting for. We jumped up to 13, so we're going to have to come back down a little bit. So go back to that, and let's try, let's just jump to 8.5, and let's try 8.6 and see what that gets us. Mass Properties, and 12,521. 12,521. That is pretty darn close. In fact, maybe if we just try that one more time, and I think this is probably getting close enough. And you notice how fast it is. It wouldn't take much to change it. But let's try 5.5. Mass Properties. 12,448, and we want 458. I'm going to call that close enough for right now. So what that's telling me right now is that much of my boat is going to be in the water. That's where my water line is going to be, and the rest of it is going to be the freeboard. So if I take that, the distance which we have right here, we just figured that out. It is 855. So we're going to have to take 24 minus 8.55, and our freeboard on this design is 15 inches, 15.45 inches, and that's actually way too much, because if you try to reach in the water and try to get some power into that, you're just reaching too far over. So for this design, for example purposes, this will work, but for actual design, I would cut that way down. 24 inches is too much. So that is how you can actually calculate where the buoyant point is, and the where your freeboard's going to be. Now let's just finish this up real quick. I do need to add another configuration in here, and just so I'm going to call it split body. Because in basic not shelled, notice right now it's showing that I want to actually modify that, and in this particular one I want to show the plane, but I don't want to show the split. So suppress that. There we have the water line, and we have the entire boat right there. So that's fine. Modify this again, default basic. I want to show that plane, so I'm going to not suppress the plane. Come back up here, split body, and there we go. So now we have a pretty good several different configurations we can jump back and forth to.